Already we have studied about motion, so let us try to first of all have a small quick revision of what we have learned. We talked about motion, then we talked about various terms related to motion, such as displacement. Then we talked about velocity. Then we talked about acceleration. Then we talked about graphs, graphical representation of motion, where we studied about two different types of graphs. One was distance time graph, and the second one was velocity time graphs. After we discussed the graphs, we derived the three equations of motion. The first one was V is equal to U plus AT. The second was S is equal to UT plus half of AT square. And the third equation was V square minus U square is equal to 2AS. And then we talked about numericals related to these three equations. And finally, the last topic of the chapter was circular motion. And we also discussed why is circular motion accelerated motion. Now in the second chapter, we would be totally concentrating on a new topic, that is force. You all have studied force in class 8. So if we go back to class 8, what is force? You have read the definition of force. The definition says a push or a pull. A push or a pull is called force. So if you are applying a force on a body, what can be the various changes that a force can do or a force can create? So a force can, number one, change the speed of the body. A force can change the direction of the body. Third can be force can change the shape of the body. Force can change the acceleration of the body. And the fifth important one is it can change the state of motion of a body. A force can change the state of motion of a body. Now, when we talk about point number 5 says a force can change the state of motion of a body. Means if we look at the statement, we mean to say that a force can a force can bring a body which is at rest to the state of motion. Or if we go the reverse way, a force can bring a moving body to rest. Now, to understand these 2 points, let us try to take a few examples. Let us say that we have a huge rock. Let us say this is the rock lying on the ground. This is the ground. Under this condition, what are the various forces acting on the rock? If we want to see the various forces acting on the rock, the first one would be the weight of the body acting vertically downwards, weight of the body or weight of the rock which is acting vertically downwards, and at the same time there is another force which is keeping the rock stationary, and this is called as the reaction force vertically upwards. So under this condition, but the upward force is equal to the downward force. Upward force, which we call it as reaction, is equal to the downward force, and because of this condition the rock is stationary. The rock does not or doesn't move. So this is case number one. Whatever the objects which we see around us and they are lying on the surface and they are not moving, this is the condition. The weight of the body is acting vertically downwards and there is a reaction force which is vertically upwards. So this is the reaction force. This reaction force and the weight balancing each other, and therefore the rock is not moving at all. Now let us take a second case. The same rock. Well, let us draw the same rock again. So we have a huge rock lying on the surface. The weight of the rock acting vertically downwards. Let us say this is W, and there is a reaction force acting upwards. We will read it later on when we talk about Newton's laws. We will learn about this action and reaction. So there is a reaction force upwards, and under normal condition weight and reaction are equal. So we have a surface, this is the ground, this is the ground. So if you want to push this rock, You are trying to push this rock by applying some force. You are giving a push to the rock. So what are the various forces acting on the rock now? The question is, what are the various forces acting on the rock? We have already marked two forces. One of them is the weight acting downwards, and there is a reaction force which is acting upwards. Now what are the other forces? The push is from the left to right. This is the applied force. At the same time, there is another force acting in the opposite direction. And what is the force? There would be a reaction force, there would be a frictional force which is trying to oppose the motion of the rock. This is the friction. So what are the various forces? Number one would be weight of the body downwards, weight of the body downwards. The second one is reaction, which is upwards. What is the third force? The third one is the applied force. Applied force is our push, and there is another force which is frictional force. So please look at the diagram. We have got a person pushing the rock. There is a frictional force. There is a weight of the force. There is a reaction force which is vertically upwards. Now, under this condition, let us imagine the weight to be, let us say 100 Newton. Let the weight of the rock be 100 Newton. Let us say this is 100 Newton force. Weight of the rock is 100 Newton. So what would be the reaction? The reaction would also be 100 Newton. So in this diagram, the reaction force would also be 100 Newton. So this 100 Newton, the downward 100 Newton and the upward 100 Newton, they cancel each other. So this rock is steady. But let us say the frictional force is, let us say 20 Newton. Let frictional force due to the ground is equal to 20 Newton. So this is 20 Newton. And applied force is also 20 Newton. Now what do you expect under this condition? We are applying 20 Newton force, which is the push. Friction is 20 Newton in the opposite direction. The weight of the body is acting downwards, which is 100 Newton, and the reaction is 100 Newton. Now if you look at the diagram very carefully, the upward and the downward force are equal and opposite, so they are cancelling out each other. So this force and this force, they are cancelling out each other. And if you look at the applied force by the person is applying a force of 20 Newton, the friction is also 20 Newton. So these two forces are also equal and opposite. So under this condition, the net force acting on the rock becomes equal to 0. So in this condition, the second diagram, what is the situation? The net force. So if we draw the diagram again, I'll draw the diagram with the help of arrows. So this is the rock. The weight was 100 Newton. The reaction force is 100 Newton. So these two are cancelling each other. In this direction we have got friction, which is 20 Newton. And in this direction we have got push. This is 20 Newton. So the upward forces and the downward forces are cancelling. So these two are cancelling each other. And the friction and the applied force also cancel out each other. So the net force acting on the rock becomes 0. So because the net force acting on the rock is 0, what do you think, the rock would move or not? So will the rock, now the question is, will the rock move? So the answer would be obviously no. Why? Because all the forces acting on the rock cancel out each other. So net force is 0. Hence rock doesn't move. This condition, when the net force acting on a system becomes 0, a condition when the net force acting on a system is 0, we call the forces to be balanced forces. So we are going to talk about balanced forces now. What is balanced force? If the net force acting on a system is 0, then the forces are said to be balanced. So what we saw is, if we apply a balanced force on a system, means if a balanced force is applied on a system, there would be no change in the state of motion of the body. I think this is clear. Now let us move on to another diagram, the same rock again, but we will have a different setup now. So we have a rock now. This is the rock. The weight of the rock is downwards, which is 100 Newton. There is a reaction force which is equal to 100 Newton. We have the ground, which is on which the rock has been placed. So this is the ground, and you are pushing the rock with a greater force now. So you are pushing the rock with a greater force. So let me draw it again. So this is a rock, and you are pushing the rock with a greater amount of force. So this is the applied force. So in the previous case, there was a frictional force. This was the direction of the frictional force. And what was the value of the frictional force? The value of the frictional force was 20 Newton acting on the rock by the ground. You can see this is friction, 20 Newton, and we had applied the force of 20 Newton. Now let us see the other condition now. Now this is the diagram. Friction is 20 Newton. Let us say the applied force is 30 Newton. So applied force is equal to 30 Newton from left to right, and frictional force is 20 Newton from right to left. If you look at the weight of the body and the reaction forces are equal and opposite, so these two forces are cancelling out each other. So what is the net force now? Net force is equal to, will it be 0? No, of course no, because one of the force is 30 Newton and the other one is 20 Newton. Net force is 30 Newton minus 20 Newton. So this is 10 Newton towards right. So what will happen to the rock now? Under this condition, the rock is going to move. The rock moves towards right. And in this condition, we say that the forces are unbalanced forces. So if you apply an unbalanced force, so if unbalanced forces are applied, on a system, then what would be the observation? Observation is, what would be the first observation? What would be the first observation? We can stop a moving body. We can stop a moving body. And the second observation would be we can bring a body at rest to motion. We can bring a body at rest to motion. So, what is necessary to create a motion in the body, to change the state of motion in a body? So, the conclusion is to bring about any change in the state of motion of a body, to bring about any change in the state of motion of a body, we need to apply unbalanced force. So what is the definition of unbalanced force now? We can define the unbalanced forces now. So unbalanced forces means if the net force acting on a system is not equal to 0, then forces are said to be unbalanced. So what we learned in this small discussion is, for bringing about any change, if you want to stop a moving ball, your friend has kicked the football. So if this is a football and you want to move the football, you kick the football by applying some force. The football comes to motion. So what type of force is applied by the kick? It is nothing but unbalanced force. After you kick, the goalkeeper tries to hold the ball, catch the ball. What type of a force is to be applied by the goalkeeper? Because the ball was in motion and you are trying to stop the ball, the goalkeeper must apply an unbalanced force to stop the ball. So unbalanced forces can change the state of motion of a body. Unbalanced forces can change the state of motion of a body. So what have we discussed today? We have discussed about balanced and unbalanced forces. So go through the video, try to understand the concept of unbalanced and balanced forces. In the next video, we are going to talk about, or we are going to have some more discussion on unbalanced forces, and then move on to the Newton's laws of motion, which are very, very important in this chapter. Thank you very much.